Greetings and welcome, friends, boys and girls. We were talking about functions, relations, and yesterday specifically linear functions. And here's a question. It says, determine whether the graph represents a linear or nonlinear function and explain. So although you might call this a line in an art class, it is not a line by the mathematical definition. This is nonlinear. You could just say because it's not a line, but linear functions have a constant rate of change. So guys, let me show you this, for instance. This is actually like really steep at first. It goes up 1 and over 1, and then it looks like it will go up 1 and then over like a lot before it gets to the next point. So it's actually, it started off steep and then it gets less steep. And then even if I go this way, it's actually, right, it started off less steep, got steep, and it's got a changing slope. It does not have a constant rate of change, so that is non-linear. So this one here, here, follow along, sit down, right, to take point. This one looks like a line. It is a line, so it is a linear function. Actually, we'll let you guys tell me, is this a function? It's linear, but is it a function? Does it pass the vertical line test? Is there only at most one point that it ever intersects with any vertical line? Then the middle one here, the orange one, yeah. So that is a linear function. And also notice that between any 2 points, down 1, over 1, down 1, over 1, down 1, over 1, it has a constant rate of change. Right, it's always the same steepness. So constant rate of change. Yep, very well, very well. So let's see, let me mark this. Very good. And this last one, these look like lines. Is it a linear function? Non-linear. Non-linear. It's got components that are straight, that are rays, but it's got a change in slope, right? We're going up 1 over 1, up 1 over 1, up 1 over 1, and then suddenly we go downhill, down 1 over 1, down 1 over. So because there's a change in steepness, it is not a linear function. By the way, this is like a cubed root function. You might see in pre-calculus. This is an absolute value function that we'll see later on at the end of this very course, this very chapter, in fact. It'll be great. Okay, we could also determine whether or not functions had a constant rate of change based on our table, right? If I've got input and output like so. Let us check the following. So notice for the x's, it's going over 2. I'm saying over because x's are the horizontal axis on our coordinate plane. So it's going over 2, over 2, over 2, because those are increasing. And for the y's, it looks like this went from -9 to going to -3. That went up 6. So it's going up 6 over 2. And now the question is, does this go up 6? No. No. Yeah, that goes up 2, so it is not a constant rate of change. And then this goes up 2, but it's already too late, so it is non-linear. Oh, man, good catch. Thank you, sir. Yeah, my bad. Wow. With the save, check out Ethan Math on YouTube. He'll help you out. So this is non-linear because it does not have a constant rate of change. So if you were to do this problem on a test or something, I would be looking for these things written and an explanation. Yeah, I think that's the way you can show it. You can demonstrate it. How about this one? Let's see. This went up 1, or sorry, maybe I should say over. So because these are constant differences between the x's, if it's linear, I would expect constant differences for the y's. And let's see, this looked like it went down 15, right? Yeah. Yeah. All right. Hey, that looks constant. So that is linear. Because constant rate of change. Excellent. Let's see. Do I have one more batch of problems, I think? A couple more in this last batch. All right. We also were able to determine whether or not something was linear if it could be written of the form y equals mx plus b. So the question is, can I write this in that form? And this one, notice I could rewrite as y equals negative 3x plus 7 if I use the commutative property there. And that's in the form y equals mx plus b, so that is good news. It is linear. Linear. This one over here, if I was to, say, distribute, Ethan, I would have the following. Y equals 32x minus 4x squared. This is a problem, this x squared part. No. This is non-linear. And actually, tell you what, let me open up my Desmos graphing calculator. I can get rid of that and that. Here we go. Let's actually put that into the Desmos. Let's see, 32x minus 4x squared. Come on here, Desmos. Y equals 32, nope, x minus 4x squared. This is actually going to be what's called a parabola. We are going to see these later on in our course. It's actually this kind of an upside down U shape, some people would describe it as. Here it's getting less steep, and then it's getting steeper and steeper, faster and faster, infinitely. This never loops around, by the way. If I was to zoom out forever, you would see that it just keeps getting steeper and steeper. It's going down, like down 1,000 over 1, down 10,000 over 1. It's just getting steeper and steeper. What? A million. Yeah, it'll reach a million. And actually, if I click on this, I could even smoosh the graph. And yeah, this thing just gets super steep. Yeah, crazy. So yeah, so that's what that graph would look like. But well, anyways, thank you for watching, internet friends. Have a good day.